whoa, wait, stop, wait, stop, no! Welcome back to the studio. It's Tuesday, the 5th of May, and the airlines are in such bad shape today, I don't even want to talk about them. So instead, today, we're going to talk about, we got a lot of questions about the recent Houston police helicopter crash in Houston, Texas, that looks like a tail rotor failure. And to help us understand more about tail rotor failures in helicopters, I'm going to bring back Scott Monroe, my friend from, all the way back in 1980. I met Scott in A&P school, and I went on to do a Air Force and airline career, and Scott went on to the Army warrant officer helicopter training and has had a lifelong career flying helicopters. So we're going to bring Scott back and explain to us more about helicopter tail rotor failures. We don't know what caused this tail rotor to fail on this helicopter, but it looks like that the tail rotor did fail and caused this crash. Scott, you may recall, was instrumental in helping us understand important details about the Kobe Bryant helicopter crash. A lot of people have been asking questions about the recent Houston police helicopter that went down near Houston, Texas. And as soon as I saw it, it looked to me like tail rotor failure. Scott, you looked at the video. What did you think?
Yeah, it was I was surprised somebody shot the video. It was like 2 a.m, so somebody was out smoking a cigarette on the balcony or something. That must have been, but so it was at night. Given that, it was difficult to see, but you could see the searchlight and the navigation position lights. So yeah, it looked like he's definitely spun it a couple of times, which is, that's tail rotor failure almost unmistakably. Of course, the regular caveats, we don't know, wait for the investigation and all of that happens, but it's pretty obvious it was a spin of some sort, which usually means some sort of completely, failure of the tail rotor. So yeah, I agree.
A mechanical failure of the tail rotor. So yeah. We, as fixed wing pilots, we're kind of terrified of helicopters. We think that's 1,000,
yeah.
1,000 parts, moving parts. Yeah, but you've been doing it all your life. 1,000 moving parts in formation, each one critical to the operation. So tell us the primary function of the tail rotor is to counteract the torque of the main rotor, right?
Right. Yeah. Like Newton's, one of Newton's laws, every action has an equal and opposite reaction. So when you're applying a twisting force to something like that, the fuselage wants to.
Your video went out. There you go. You're back.
This is
the tail rotor again.
It just compensates for the twisting force that the engine applies to the main rotor. If you didn't have that, you would spin, very aggressively. And so you've got to have that as an opposing force to keep it straight during most flight regimes.
And that also is effectively your rudder in a helicopter. It gives you the yaw motion, and that's what you correct. Control with the rudder pedals in a helicopter.
Correct. Yep.
Now, a tail rotor failure is not necessarily a total loss all the time. You can recover a helicopter with a tail rotor failure if you have enough altitude, right?
Yeah, or you're low enough. Strangely enough, if you're like, say, in a hover, a 3-foot hover, and you did that, if you react quickly and get the power off, that's the important thing up. The torque has to be removed. Once you get that anti-torque gone, you have to remove the power. So chop the throttle. If you're at 3 feet, it's a simple matter of just cushioning with a little bit of, collective pitch, and you're down. If you're high enough, yes, you can recover, but you have to get some forward airspeed. That's the thing. If you're coming down vertically from a height, depends on a helicopter, but it's too high, the rate of descent in a vertical auto rotation is too high to survive. And you don't have enough inertia in the rotor to cushion that at the bottom, with collective pitch.
But
if that makes sense.
if you're high enough, you can lower the nose and basically do a forced landing glide down. And if you're low enough, you can just set it down. But if you're in the middle, you're kind of doomed.
Yeah, exactly. actually, every helicopter has a height velocity diagram for auto rotation. So this is just an auto rotation, same profile, but you're just missing the directional control that the tail rotor offers. So you got to think of it as just an auto rotation. If you happen to be operating in that area, that the height velocity diagram says it's not possible to pull off an auto rotation, and that's all printed in every pilot operating handbook. A pilot's supposed to know this, kind of like where these areas, it's airspeed versus altitude, and if you're in there, it's not survivable. You can't do it.
But there's something about police operations that puts them in that danger zone all the time, isn't it?
It can, if they want to slow down into a hover, and yeah, it's up to the pilot to operate it in that regime. If that happens, any single engine helicopter guy is going to know this by heart, particularly because you just don't have an option. The engine fails, you're auto rotating. You're basically going down whatever it gives you, so no different here. Something like that happens, that's a tough one.
And so what is it that's so fragile about tail rotors that they do occasionally fail? As you're an A&P mechanic,
I don't know that they're really fragile. It's like you said, there's a lot of parts. You've got a drive shaft and the transmission running back with the several hanger bearings, to support it along the tail boom. Then you've got another 90-degree gearbox back there. And then you've got pitch change links and all this stuff that your pedals can run it. So there's a lot of, linkages and things to fail. So, and there's a lot of force on that too, you don't realize how much torque is actually applied to that shaft all the time, but I really don't even really think about it. I've never experienced any kind of glitch in 35, 40 years of flying helicopters.
So it's extremely rare to have.
It is, yeah. Nowadays with modern helicopters, the materials and the science behind it is well proven, and just like airliners and any other aircraft, you've got redundancies, you've got material that are very advanced, and mechanical failure is not any more. I would say the modern helicopter is not more susceptible to mechanical failure than any modern airplane would be. In my opinion.
And this helicopter was a what model? And the single engine helicopter?
Yeah, it was a Hughes. I don't know, Hughes, McDonnell Douglas 500 series. Yeah.
The old Hughes 500.
Correct. Yeah.
Mm-hmm. Which is a single engine turbine helicopter.
Single engine turbine helicopter. Yeah, mm-hmm. It uses the same engine as a real familiar Jet Ranger. Outstanding helicopter, well proven. They flew them in Vietnam even. I think the first one flew in was 62 or something like that. So been around a long time.
Is there some helicopter designs that don't use a tail rotor, that use a fan blower instead?
Yeah, actually McDonnell Douglas has that. What was it called now? But yeah, it uses a fan in the back and then this slot along the tail boom, and then just a kind of like an exit for the pressurized air in the back, which they direct around. So gets rid of the whole tail.
All the monkey motion there, and they just change the size of the opening of the blower
and the direction of it. Actually, they change the direction the slot's pointing. Yeah,
it's like like a jet ski or something.
Yeah, well, the bigger danger with the tail rotor is not. Yeah, tail rotor is not a failure, but it's because you're operating a helicopter maybe in a confined area with trees.
Yeah.
You hit that on the ground. You hit that on even a rag thrown into it will make it fail. There's so much stress on it. We did have a helicopter in my company a year or two ago, was landing in a field and ingested like a beach towel or something, like just a wash rag or something, flew up into the tail rotor, and boom, that was it. It just sheared it. Ooh, so yeah, he was on the ground when it happened, but yeah, if that had happened in the air. So when that McDonnell Douglas design with no tail rotor gets rid of that danger, which is a pretty cool deal.
Gotcha. Now, as far as controlling the helicopter, once the rotor fails, folks say, "Oh, he steered it. The witness is on the ground, says he's such a hero because he steered it away from this or that or the other thing." You don't have much of a choice.
Maybe. No, you're going straight down. You're going straight down. And look at the spin. So you don't realize how physically disorienting that is in the daytime, let alone at night.
Yeah.
It gets so bad. If you go around maybe twice at that velocity without pulling that power off, it's so disorienting. The G's start pulling you forward. And I've heard the story. I've never experienced this at all, and I don't want to. But guys that have pulled it off you go around twice and you don't know where you are. Okay, it's like getting on a merry-go-round times 10. It's just disorienting. So to try to pick out a spot in the middle of this, maybe. More than likely, though, he was in survival mode and just lowered the collective, and you're going to take whatever the situation is given you, you know.
So the basic procedure, if you've got altitude, is to get off the power, lower the nose, increase the speed, and then work your way down and flare without power, like an auto rotation. Yes. And as long as you're coming down, you don't have power on, you don't have torque, you're relying on the rudder to start working like an aircraft rudder.
Right. It's just streamlining behind you, and that's going to keep you straight so that you can, you know, somewhat remain oriented to what the control inputs will be. Because you get sideways and, you know, now your left stick and everything's all screwy. You know, you have to get stabilized a little bit.
Now, when you come down to flare, you pull the collective. How does the thing start torquing the other direction with the rotor?
It does. Yeah, that's the funny thing about it. Since you don't have power applied, that's not a problem. But then the drag of the rotor shaft up through the transmission and the gearbox and everything else like that tries to pull the fuselage around to the other way in the direction of the blades rotating. So that can be a problem. It's usually not bad, they say, though. It might turn 180 or something. You know,
180 degrees?
Yeah, it could be at the bottom.
You're going to come in and wipe out like that?
Well, in the flare, like as soon as the RPM starts to drop or your airspeed starts to drop, it's going to start to turn.
Wow.
Yeah. And it's not violent or anything. It's a much slow turn, you know.
So the first step is to get off the power to stop the spin.
Yeah. ASAP. Yeah. Man. Immediately. That's why they put a twist grip right down there where your hand is. That's where the throttle is. And you just you just roll that off with your, kind of like a motorcycle.
Like a dirt bike. Yeah. Or a motorcycle.
Yep. There you go.
Wow. Huh. Helicopter operations with Scott Monroe. Man, thanks so much for helping to explain all that this morning.
Yeah, you're welcome. Condolences to the families out there that lost the individual. They're good guys and do a lot of hard work for us. So it's a shame.
And man, operations in that envelope area are well, that's the utility of a helicopter, though.
That's true. You just have to be mindful of where you're operating. It's just like an airplane. You know, you fly at altitude. You don't want to be in that coffin corner between stall and Mach, right? You know.
Yeah. We got operating limitations.
Of these things. Mm-hmm. Right. Exactly.
Yeah. Okay, Scott Monroe. Thanks once again.
All right. See ya.
Talk to you soon.